here we want to displace the block by applying minimum force, and we want to find that minimum force and at which angle we have to apply. So FBD, free body diagram of this figure. This is the block, this is the surface. The coefficient of static friction between the surface and the block is mu, and suppose we are applying force F at some angle theta. This F has two components, F cos theta and F sin theta. It is downward, normal force is upward. But there is no motion of the block in vertical direction. So vertical forces must be balanced. So N plus F sin theta is mg. This is the equation number 1. When the block is on the verge of motion, at that time F cos theta just balances Fs, and at that time Fs is Fs max. That is, when the block is on the verge of sliding motion, F cos theta just balances Fs max, and when it just exceeds, block will slide. So F cos theta equal to Fs max, but Fs max we know that mu into N, but here normal force is mg minus F sin theta. So normal force is replaced by mg minus F sin theta. Now again from this equation, F cos theta equal to mu into N, but N is mg minus F sin theta. Simplifying it, F cos theta equal to mu mg minus mu F sin theta. So F cos theta plus mu F sin theta is mu mg. Taking common F, we get cos theta plus mu sin theta equal to mu mg. So F is mu mg upon cos theta plus mu sin theta. Here mu mg is constant from data because of mu is given, mass of the block is given, and we want F minimum. For this, the denominator, this one, should be maximum. To find at which angle theta the denominator is maximum, consider this one as y equal to f of theta, because it is a function of theta. So cos theta plus mu sin theta, and this term should be maximum to become f minimum. Now using the geometry, consider this triangle. Say this one is phi, this one is mu, this one is 1. So this one, hypotenuse, is root 1 plus mu square. So multiplying by root 1 plus mu square and dividing by root 1 plus mu square. So after this, root 1 plus mu square equal to sin theta into mu by root 1 plus mu square plus cos theta into 1 by root 1 plus mu square. But from the geometry of the figure, cos phi is mu upon root 1 plus mu square. This is cos phi. And sin phi is what? The 1 by root 1 plus mu square. So this one is sin phi. So root 1 plus mu square into bracket sin theta cos phi plus cos theta sin phi. So root 1 plus mu square, this is maths, sin alpha cos theta plus cos alpha sin theta is sin alpha plus theta, similarly sin theta plus phi. Now we can say that when theta plus phi is pi by 2, at that time sin pi by 2 is 1 and it is maximum. So when theta plus phi is pi by 2, then y is maximum, and so f becomes minimum. So considering theta plus phi pi by 2, f minimum, so mu mg upon this should be maximum, but this one is maximum value is root 1 plus mu square. So minimum force is mu mg upon root 1 plus mu square, and from the geometry of the figure, because we want to find theta also, so theta plus phi is pi by 2. This one is pi by 2. This one is phi. So this angle must be theta. Now using the geometry of the figure, we get tan theta is opposite side upon hypotenuse. So tan theta is mu by 1. So theta is tan inverse mu. Now check point. Consider the frictional force is infinite. Suppose mu is infinite. So whatever force I am applying, I cannot displace it by horizontal because of mu is infinite. If we consider hypothetical idea. So for this, if you want to displace, we will apply force at 90 degree angle, almost 90 degree, 89.99999. And when it lifts, there is no friction, there is no longer friction because normal force is 0. And at that time we can displace it by applying force exactly equal to weight of the block, but at nearly 90 degree angle. And if mu is 0, at any angle, if we apply nearly 0 force,